Okay, you're asked to find the solution or solutions to this equation right here. And that's the same as finding the solution to this equation. Just subtracted these terms from both sides, got it equal to 0. And that's the same idea as finding the roots of this function. And that's what this red graph is. It's the graph of cosine of x minus x squared plus 4. It sort of looks like a parabola, but it really isn't a parabola. And so I'm going to try to give you an idea here of how and why Newton's method works. So you need an initial approximation for a solution, something that's close to where this red graph crosses the x-axis. -2 looks like a good starting point. So that's what we're going to call our x sub 1. Some textbooks call it x sub 0. And if we could get the equation of the tangent line to the curve at that point, well, let's see how we do that. The point is -2, f of -2. That's what this is right here, f of -2. So we use point slope, y minus f of -2, so the y coordinate of the point of tangency equals the slope, which is f prime of -2, which here's f prime right here, times the quantity x minus x sub 1, or x minus the -2. So if we simplify this and move this term to the right side of the equal sign, there's the equation of this tangent line right here. Now, when does that graph, or when does that tangent line cross the x-axis? Crosses the x-axis when y equals 0. So if I solve this for x, it ends up I have a better approximation for the root. So here's what I did. I subtracted f of -2 from both sides, then divided by f prime of -2, and then finally subtracted this 2 from the other side to this side. And there is the x-coordinate of the point where this tangent line crosses the x-axis. Now, if I would find f of that new value, I'm calling this x sub 2, by the way, and go through the same process, I could get another tangent line, which would even get closer to the approximate root. Okay, so I'm going to share my screen. Whoop. Desmos. And there's the graph. Whoops, no, I wanted to go here first. So there are the two tangent lines. And if I narrow in on what's actually happening, it's hard to see, but here's where the tangent lines are crossing the x-axis. And you can see the second tangent line is much closer to the red graph. We're getting closer and closer as we use subsequent x values. Here's what it actually looks like with Newton's method. Okay, there's the function. There's Newton's method, your initial approximation minus f of x over f prime of x. And we started with x sub 0 equals -2. There's the initial tangent line. And then I use this value in Newton's method, n of x sub 1, that gets me closer. X sub 3 is n of x sub 2, and so on until these start repeating. So there is an approximate root for, looks like it only takes 3 invocations of Newton's method until all these decimals start repeating. So to 6 decimal places, -1.9140221, it looks like. Okay, now that's one of the roots. There's another root over here. And if I go over here to initial value of 2, I'm getting the same value, only positive value. Okay. And if I go like this, there's what the initial approximation looks like. Okay, there you go. Well, if any questions, post a comment.